Okay, now we have one more scenario to deal with. That is, we like to generate the scenario where we have two depots, and each depot have one vehicle. Okay. Now let's first take a look at this map. We're gonna turn off this. So on this map, we have all the demand. Let's see, all these. We have a road. We also have these 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 consumer locations, and this is one depot. So we want to add one more depot. We like to let's first select the point where will be the location of second depot. Second depot should be in a place the fairly distance away from the first depot. Let's go to the spreadsheet. Go to the attribute table of VRP center. Okay, let's see that this is the VRP here. Here's VRP attribute table here. So we know code one is one depot, and let's see. Let's choose point 47. Point 47 is here. Let's select 47, and the point 47 is somewhere here. So fairly distance away from the first depot. So let's pretend that okay, we're going to choose point 47 at the location of the second depot. Okay, so we're going to have two depot. Says okay, let's say point code 47 going to be the second depot. Okay, so now this is what we decide. So now let's go to R. Okay, in R, let's go to R script, edge list matrix conversions. Okay, let's first reprocess the edge list that we created early on from QGIS. Let's bring in edge list 48 new. Okay, let's go into get that. Okay, go to get edge list 48 new. Okay, this is the one. Okay, let's take a look. Take a look at this edge list. It looks like this. Looks like familiar to you? Okay, edge list 48 new. Okay. Now let's first make that into a matrix. We run this block. Run this block. After that, we also want to make the take a look at the matrix. So this matrix, one thing that we need to do is that we need to change the diagonal value into 0. That is what we do here. The diagonal value becomes 0. Okay, here. Now I want to do one thing that is very important. Okay, so now I add one line here. Okay, add one line here. So you want to follow me to do it. We want to look at this distance matrix in spreadsheet because there's something that we want to change. So text, just type fix, and within the parentheses put in the name of this distance matrix. Then you run it. Then this distance matrix show up in this spreadsheet. You can make some changes on this spreadsheet. Okay. Remember, right now, code 1 is the location of one depot. We also think that we want to make code 47 as the location of another depot. So we want both depots are ahead of all other locations. Therefore, we need to recode location 47. We recode that into 1.1. It's in the spreadsheet at this location of 47. We retype it 1.1 to recode that. Same thing for column. You go to column number. For column 47, you change that into 1.1. Okay, and that's ready. So we change. So we recode row 47 into 1.1. We also record column 47 1.1. Now let's move into the second part of this script. We change the matrix into edge list. We run this line. We change it into edge list. Now let's take a look at this edge list. After we run the first line, this edge list, you can see that there are location 1.1. So the location 1.1 occurred here. So we need to this location 1.1 right here, location. So 1.1 here. So that is what we're trying to do. We get rid of 47. We change that into 1.1 so that eventually it can appear on top of all other locations. Okay. So now that's the same thing as we did before. With this new edge list, we're going to convert the distance from meters into kilometers. We also want to resort this distance, resort this edge list, so that the smaller value go first, larger value go later on this line. Now let's take a look at this new edge list. So now we can see very clearly you have a 1 and 1 followed by 1.1. So that is what we want. So now we effectively change both depots on top of all other consumer locations. Okay. So this is what we did. Now let's move on to the section in our script, 2 depots. Okay, 2 depots. 2 depots, this script basically is rename code 1 into depot A, name code 1.2 into depot B. That is what this is trying to do. Okay, so we already sorted that, no longer to resort that anymore. Okay, and now let's go to run this first block. We recode depot A, recode code 1 into depot A, and second block we recode code 1.1 into depot B. That is what we do. Okay, then we take a look at this. You see, depot A and occurred there, and okay, we need to. Okay, then we run this line. And let's take a look at after we record. So depot A and depot B. This is all occurred correctly. So that is what we want. Okay, now we save. We save this edge list for 2 depots as edge list 40A new 2 depots. Edge list 40A new 2 depots. 2 depots. So we know. Okay, and say open. And do you want to create this file? Yes. So now we are ready. Now we are ready to go to Excel spreadsheet solver. Okay, go to Excel spreadsheet solver. Look at this. Let's go to Excel spreadsheet solver. Go to reset the spreadsheet solver. Okay, and go to this. Bring us to this cover page. Now, number of depots we type 2, and the number of consumers 46. So we have a total number of 48 points. 2 of them become depots, so there are 46 consumer locations left. Manual entry for distance, yes, and number of vehicle types, just 1 type of vehicles. Vehicle must be returned to depot, yes, and we don't do visualization in Excel. Warm start, yes, and their recommendation at least 60 seconds. Okay, which is what we can do 120 anyway. So okay, so we do 120 second, 120 seconds. Now we go to locations. Set up location worksheet. Okay, setup location worksheet, you see the location worksheet is depot A, depot B is already there. So we need to put in the location for other customers. Let's go to vehicle VRP center data. So we know that the code 1 is a depot. Code 47 is also a depot. So what we need to do is to type to replace 47 by 1.1. And we resort this data set. We highlight from the bottom to the top, go to data, sort by code from smallest to the largest. After that, you can really see that the 1 appear first and followed by 1.1, which is simply 47. And all we need is here from 2 through 48 without 47 in the middle. So we copy from 2 to 48 without 47 and come back to the spreadsheet. We paste this on the name after depot B. Okay, we just paste. So that is our customers. And then we'll put in the amount of delivery. Okay, let's go back to the same sheet. VRP center value would check from, we start from code 2, go to the bottom, go to 48, and this is the amount that we need. And don't forget that this is going to be paste 1, 2, 3. Okay, paste value, not the formula. So this is the value we need. So this is the amount of delivery we need. So we set up these locations. Now we move on to number 2, distances. Set up distance. Okay. Set up distance. This is the column number 3, the C column. Distance, just something we need to put in. So now let's go to bring up the edge list we saved from this edge list is called edge list 48 new to depots. So edge list 48 new to depots. Open that. Okay. So this is what we have. The distance we need is this. From the very beginning, depot to depot A, all the way to the end. Okay, 0, 0. And bring that into spreadsheet solver. We paste into column C the distance and say paste, and that's done. Okay. And on top, select VRP spreadsheet solver, go back to vehicles. We set up distance already. Go to vehicles. Now we have 2 rows because we have two depots, depot A and depot B, and each depot has 1 vehicle. Okay, so let's type in capacity. Let's assume that each depot carry half of the delivery. So let's see the total amount of delivery. Let's go back to VRP data. Total amount of delivery is about 260. So let's each depot will take care half of that. Let's put slightly more than half, 140 each. So go back to this. And the capacity for each vehicle is 140. 140, okay, 140. Okay, so it automatically gives you the other half. Now let's see the distance limit. Okay, we know the half of we just assume that for each depot it takes care of half of the distance. We know the total distance already. The total distance is simply let's recalculate the distance. Just give you a sense of how we do this. So let's go back to the edge list from 2 depots. Edge list 40A new 2 depots. We calculate the total distance. Total distance again about 34,000. So let's assume that each depot take care of half of that. So each depot take care of 17,000. Okay, so go back to type in 17,000. This is the limit. 17,000 limit. Okay, that so that's done. They take other columns, other. We don't deal with more complexity, complication with the time. We don't deal with time here, and number of vehicles for each depot is 1. So we're done with vehicles. Go to solution. Set up solution, and it will take 2.8 seconds. Do you want to continue? Yes. So now, okay, again we can see the spreadsheet is split into two halves. One side is depot A, vehicle 1, and the other side is depot B, and vehicle 2. So now let's 2 vehicles and 2 depots. So again, let's just arbitrarily put a half for each depot, half of the consumers for each depot. Go back to VRP center data. Let's take consumer from 2 to 22 and to the first half, because no matter what we put, the computer eventually may change that. Okay, and place so 2 to 22 go to depot A, and the rest of the customers will go to the other half, go to the other depot. Okay, 23 to 48 without 47 go to the other depot, put on the depot B, and in both cases we need to add with depot. So this first part deal with end up with depot A. So start from depot A and back to depot A. For this second half, we start with depot B, back to depot B. Okay, this is our initial solution, one of the solutions. So start from depot A, go to 2, 3, 4 until 22, and back to depot A. And this side start from depot B, go through 23, 24 until 46, 48, and back to depot B. This may not be optimal, and that's why the computer will decide what are the better solutions. Okay. Now let's go to solver and check 6.2 feasibility check. Is that feasible? Solution is feasible. Now let's go to engage VRP spreadsheet solver. It will take 120 seconds. Do you want to continue? Yes. So we wait until we come up with results. Still thinking. Still thinking. Okay. let's have a solution. Let's say, okay, we want this better solution. Okay, here's the solution. So you can see this one side is start from depot A, go to 39, 38, 31 until 414 back to depot A. The other side say that you start from depot B, going through 24, 29 until 46, 37, 32 on depot B, back to depot B. So let's just copy from depot A to depot A into a new spreadsheet. A new spreadsheet. So this is the copy paste 1, 2, 3. Okay. Now here we change depot A. We know depot A is called 1. We change depot A to 1 and depot A 1. So 1 to 1. So we call this tour. We save this as a CSV file. We call it the tour. Let's see, what is the tour? We'll call it the tour. 2D, 2B, 2D, 2B, and 1. So it's a 2 depot, 2 vehicle, and first vehicle. Okay, so that is what we call this. Okay, so that's let's go back to copy the other half of the solution from depot B to depot B. Copy this. Okay, we copy and create another new spreadsheet, and we paste 1, 2, 3, and change depot B. We know depot B should be 47. So now it's very important to change 47. Change depot B into 47. So depot B into 47. Okay, and the column name is tour, and we save this as a new CSV file. And call it 2D 2V2. 2D 2V2. Okay. Okay. So now we're gonna go to R to process the tour data to generate the maps. So first, let's just create a quick easy map. Okay. And the process exactly the same as we deal with 2 depot 2, 1 depot 2 vehicle situation. Let's first go to this generate quick easy map using VRP route 2020. Okay, we first bring in the tour data. Okay, go to the tour. We know the tour, we call it tour 2D 2V1. This one. Okay. Then we just take a look. Everything looks good. Okay. Now let's just run this big block. We start from this matrix, go all the way down to the bottom, and all the way down to until here. Run this script. Go all the way through it, and take a look. That looks right. Okay. So let's save that as max df 2D 2 depot 2 vehicle and 1. Yeah, okay, that's good. Now let's bring in the second tour data. Bring second data. Okay, second one is called tour 2D 2V2. This one, tour 2D 2V2, and take a look. So from 47 to 47. Okay, let's run this graph from this line all the way down to the line that here. Okay, let's go. Let's take a look. Looks good, and we save that as CSV file. We call it max 2D 2v2 max 2D 2v2 open and yes. Okay, so now let's go to QGIS. So go to QGIS. Let's bring in this add layer. Now add delimited text layer, because go grab first one. First one is called max D df 2D 2v1, and add and go to get the second one, max df 2D 2v2, add and close. And let's make that make those both favor thicker line. Okay, 1, 2, 3, 4. Okay, thicker line. One of them, and the second one has thicker line. Second line. Okay. Now another thing is that since we have two depots, we want both depots to be to show up clearly. So go back to VRP center, and on this you can go back to select VRP center. You go in to select line 47, 47. So it's is selected, and then you go to again keep selecting VRP center. Go to layer, save as, and you save that as shapefile, and go to a place to save that as depot code 47. Code the shapefile as depot code 47 because we use 47 at the location of second depot. Save. Before you say OK, check save only selected features. OK. And now we have a new shapefile that has only one point. Go into make that more visible and change the color into bright red and make that size into larger size. Larger size. Okay, so now we have the depot location very obvious. So this is a quick, easy map. Now let's do one more thing. Go to R to create a better looking map using an R script VRP route 2 lines 2020. Okay, so all that we need to do is repeat what we did before. Bring in the tour data twice. Okay, first let's bring in a tour 2D 2v1. Okay, and take a look. Good. Start 1 back to 1. Okay, so now let's generate this big block of information. Is there. Then we create the coordinates and we check this to see whether all points are covered by the graph line, and we see there's no NA line, so we are ready. Okay, so I'll make a map here. Let's see, just we'll run this block. You look at the map, you can see the red line will appear on the map. So that is one depot from one vehicle, and we further process this. We save the shapefile. Shapefile as VRP 2D 2v1. Okay, VRP 2D 2v1 shapefile, and go back to it one more time to bring in the tour second time. Bring the tour. Tour is called tour 2D 2v2. Tour 2D 2v2. Enter and take a look. It's correct from 47 to 47. From 47 to 47. Okay, so let's run this block of code, and also we want to see whether this 900 meters is enough. Okay. Yeah. Okay. All points are covered. So now we run one more line. Now you look at the map again. You can see the other part of the map will show up again. So we run this block. You look at the map. We run this line. Okay. The other the other part of the line will show up. So now further processing. And make sure that those lines are run. Okay, so now we save the shapefile. Save the shapefile as, we already know what the shapefile is. Should be VRP 2V, 2D 2V2. So VRP 2D 2V2, 2 depot, 2 vehicle, and second vehicle. So now let's go to QGIS to bring up those better maps. So I turn off this quick easy map to add layer. Now we add vector layer. First we add VRP 2D 2V1, add, and go grab the second one to get the VRP 2D 2V2. And open, add, close, and we'll make them more visible, and to make the line thicker. Just one of them, and then second one, two of them. Okay. Here we go. So now so this is the end of a project 2. So it's a pretty interesting project. We use a combination of software, R, QGIS, and Excel to complete this project. And the result is like almost like what you have to do with Google. You find a road, you find a direction, and come up with a precise roadmap and tell you how to go about doing the delivery. Okay, so now at the end of this the project, you're going to see that you need to repeat the whole project to generate those maps, turn it in PowerPoint. In addition, you have a challenge questions to do as well. Okay, all right, I see you next time. Goodbye.